Hey everyone, welcome back. Hope you all had a great first week of class. It was good to get back into the swing of things for school. Um, I thought the first week went pretty well. I'm pretty happy with how things are. This week we're going to talk about the roles that Linux can play as a server and as a desktop operating system. And you'll read a chapter on the Bash shell, an introduction to the command line. Um, and I want to remind you all that, to make use of the discussion board on Blackboard to ask questions to me or, to discuss with your fellow students, work things out. I'm happy to answer questions there. And for this week, I'll be posting a discussion starter for you all to participate in. Look for that to be posted on Blackboard about the same time as the lecture and slides go up. So let's jump in. So when we talk about roles for Linux, here we're going to talk primarily about server and desktop roles. Like most other operating systems now, there's the roles for Linux actually range from servers to desktops down to tablets and phones and all of that. We're gonna talk about servers and desktops here. And one thing to think about now is it used to be when we talked about servers that was a discrete piece of hardware as well, so that you had a server, an actual physical box that ran a single copy of the operating system, and that was your server, and it could serve one or multiple purposes, but each server was a distinct unit of hardware as well as an operating system. And nowadays, with virtual computing and containers and that, it's not so much the case that when we refer to servers that we're also talking about the physical hardware, a discrete unit of hardware, and an operating system. Now you have cloud computing. You have things like Amazon's Elastic Compute Cloud. You have Rackspace. You have Heroku, where you bring up a server, and your server is actually a virtualized server sitting on top of a much larger piece of hardware that is hosting any number of other virtualized servers. Uh, so now it's more the case that when we talk about server, we're talking about an instance of the operating system, which could be running on a directly on a physical piece of hardware, or it could be a virtual server running in a cloud. So server applications, the servers are usually run unattended, and what that means is that they're running without somebody sitting in front of them, maintaining them and taking care of them all the time. They're in a data center, either a data center you own or in a cloud data center like Amazon provides, or Rackspace, and they chug along doing their work largely unattended without anybody really being on them, or directly maintaining them on a minute by minute basis. Of course, there is maintenance work that goes on, and there's monitoring and things that need to be done, but it's not an interactive kind of thing. Um, some of the server roles that it can play are a file server, serving up files to clients. Um, Web servers, I'm sure you're all familiar with web servers. It's the primary interface of the internet right now is web servers. That's how we all interact with the web. There's mail servers, sending and receiving email, and there's a whole chain of events that goes along with that. There's the application server, where the server runs some application software that clients can interact with. In some ways you could consider a web server to be an application server, but here we're talking about big, you know, back-end applications that generally aren't web-based. And then there's databases, and then infrastructure. And infrastructure servers are, they're kind of the back, the hidden shadows of the server world. They sit behind the scenes and run the services that let all of the public services that you see and interact with work. Things like DNS, the domain name service, that allow you to look up names, like when you go to Google.com, that gets translated to an address by the name service. And then, of course, Linux can play desktop roles as well. You're all using Linux on the desktop, either virtually or directly on your desktop computer. Um, Desktops, also known as clients or workstations. Traditionally, in the Unix world, they would have been called workstations or clients, being clients of the big servers, so that the clients were smaller, lighter weight computers, and much of the heavy lifting was done on a server. Workstations, generally are thought they tend to be more heavy duty, and clients tend to be thought of like thin clients where it's just enough to connect to the server. Although that's not always the case. Any computer can be a client of another computer. Workstations were generally a little more heavy duty than a regular desktop PC, but now with commodity hardware and Linux, anything can be a workstation. And in fact, we're all walking around with small light laptops that are much more powerful than the servers and workstations of not even that long ago. A desktop is generally is for interactive use. It's going to be something you're sitting in front of. Sure, you're all familiar with that. And generally now desktops will have a graphical user interface. And one of the big functions that a desktop workstation plays is in development. And a development desktop is kind of a specialized desktop. It doesn't just have your basic desktop software packages, spreadsheets, word processing. That it has a bunch of extra resources installed on it, libraries and compilers and tools specifically for software development. So the first server application we'll talk about is file servers. And a file server is, the web becomes kind of the general language. The web service becomes kind of the general language of the internet. And you can, of course, serve files up on that and download them. But file servers, when I'm talking about file servers, it's not really downloading and uploading files. This is a server that provides a file system to your client. So you can mount the disk on the server on your client as if it were a physical disk. And there's a couple main ways that's done. There's the network file system, or NFS. That's the native Unix file sharing protocol, and it's been around for a long time. And most operating systems now support that, and have for a while. And then there's Samba, which is the Unix implementation of the Windows file sharing protocol, the SMB protocol, and that allows a Linux box to act as a Windows file server and speaks the native file sharing protocol for Windows. And then much lesser used, but still around, is Netatalk, which is the Unix implementation of the AppleTalk protocol for acting as a file server to Mac computers. That's much less used now that since Apple went with OS X, the Unix operating system, which natively supports NFS and also supports Samba. So running an AppleTalk file server on a Linux machine is much less common, but it still does happen. And the service you're all probably most familiar with, web service, that the service behind all of the web pages and websites you use on the internet. Web servers run a protocol called HTTP. That's the Hypertext Transport Protocol. And it can serve static or dynamic content. Originally, the web was built on static content. There was no way to really serve dynamic content. And as it grew and as more development happened, people wanted dynamic content, and so there were developed ways to do that. And dynamic content can be backed by any number of languages on the back end. So you have the web server, that talks to a back end, some sort of application or a dynamic scripting language that serves up content. And that can be done with PHP or Java or Ruby or Python or any number of other languages. Anything that can has an API that the web server can hit and can feed back data, uh, can be a web backend. Um, Web servers themselves, web server software, the two most popular web server software engines are Apache and Nginx. And between the two of them, 65% of websites use one or the other or both. In a lot of cases, it's both. Nginx is designed to be smaller and lighter than Apache and to be really speedy at serving static content. There are ways to use things like PHP with it. Um, but in general, if Nginx is serving dynamic content, it's acting as a proxy to something else that generates and serves up the dynamic content. Whereas as Apache is a little larger, a little more robust that way, in that it has plugins and modules for actually uh, running, like running PHP natively or Perl or Python within the server, so that it actually serves the dynamic content itself. And of course, along with web servers, the internet service you probably use the most would be email. And mail servers run, you know, a mail server is actually a collection of a few different services that run internet email. Um, the first being the mail transfer agent, and that's the mechanism that moves mail between servers. So when you connect to your email address, to Gmail, and you send email to someone who's on Yahoo, or send email to their Facebook address, or to any number of other mail services. Uh, the software that sends the messages between servers is the mail transfer agent, and the two primary ones in the Unix world are SendMail and PostFix. SendMail being the older of the two, was written many years ago and is still around, and then PostFix is kind of a clone of SendMail, but written to be a little more a little more modern, and written kind of with a little bit more security in mind from the beginning, whereas SendMail has more security now, but it was added in. It's a much older piece of software. Um, and then once the mail is sent between the machine, between the servers, then on the server there's the mail delivery agent, or the local delivery agent, and that's what takes the email and puts it in the user's mailbox. And if it's pure Unix to Unix email, or Linux to Linux email, the SendMail or PostFix will receive it as the mail transfer agent, and then put it in the user's mailbox as the mail delivery agent. But there are other things that can sit in between there. Notably, there's a piece of software called ProcMail that receives the mail for you when your mail is delivered on a Linux or Unix server, and then you can use ProcMail to apply any number of rules for resending email, or filtering based on keywords, or subject lines, you know or filtering mail and sending it to different mailboxes. Now that all seems pretty straightforward. You go to Gmail or whatever mail client you're using, and you can set up rules and put things in mailboxes, and separate things out and filter out on any number of ways. But back before, really there were graphic email clients and all that, when you were logging into a Unix box and reading your email in a terminal screen, ProcMail was the thing that did all that for you. And most of the functions of ProcMail are still around, and what you see in your mail client for setting up rules and filters. That's all the same kind of things that ProcMail did a long time ago. And then two of the common ways of getting the email from the server where it's delivered to your mailbox to your mail client are the Post Office Protocol, or POP, or the Internet Mail Access Protocol, or IMAP. And these are in general the way that your mail client on your local desktop or laptop, when you download your email or check your email, they're connecting to a mail server where all the mail is received and stored, using one of those two protocols to download the mail and show it to you and store it on your local machine so you can read it. And there are a couple different Linux packages that are used. Two of the popular ones that are used to serve that purpose on a Linux machine to act as the server for POP or IMAP are Dovecot and Cyrus. Another very big function for Unix and Linux servers is as database servers. Um, Much of the dynamic web is served up with databases in the back end. Most of business runs with databases. Databases are a really fundamental part of any kind of server software setup. And basically, at heart they just receive, store and retrieve structured data. So traditionally, databases are what are called relational databases, where you can have different databases, different tables, and there's relation between them, and it's very structured. When you create a database, you set up, the columns you want in your database. You can kind of, if you're familiar with Excel or spreadsheets, that's kind of how a database is set up. There are columns, so you have your columns that define what pieces of data you're storing, and then you have rows, and every row is an entry in the database. And some of the common databases in use on Linux are MySQL and Postgres, or PostgreSQL. Those are both open source projects that you can download and use. But there's also commercial databases. Notably, Oracle has its own Linux distribution, and there are versions of Oracle that run on Linux very well on Linux. Um, Relational databases all use kind of, with some variation, but a common language called the structured query language, or SQL. And that's how you build queries to the database to either update or add data, or to query it and get data back. Relational databases are built with the concept of ACID. They're atomicity, consistency, isolation, and durability. And what that means is that a relational database is built around the idea that your data is safe and protected at every step of the way. It's built around the idea of anytime there's an update made, that update is consistent and durable. It's secure, so that you're not losing any data, and as soon as an update is made, it's available to all clients querying the database. In contrast, there are now a whole other class of database servers called NoSQL databases, and these, as you might guess from the NoSQL name, that they don't use the structured query language, the SQL language that relational databases use. That is generally true, but not totally true, in that a lot of the NoSQL databases do have their own, simplified or hopefully easier to use query languages, but a lot of them do also have SQL interfaces, so you can use standard SQL or SQL-like queries to get data out of them. And NoSQL databases are designed to be, the idea is that they're much more flexible. In most cases, you don't have to have a set data structure when you create your database. They act as, generally as like key value stores or data structures, or you can think of it as a document store, things like that. And you can put in, the rows can have any number of different types of data in them. You're not limited by just the columns that you defined when you created the database. Some of the popular NoSQL databases are CouchDB or MongoDB, Redis, HBase, and Cassandra, and these all are in the same class, but they all do things a little differently, and they all have their own strengths and weaknesses. So, which one you use, really kind of depends on what it is you're trying, your use case and what you want to do with it, and what kinds of data you want to store. They're all built around that free-form data storage, but in their own kind of way. Like I said, they excel at different things. And the NoSQL databases are built around the base concept. They're basically available. They're soft state and eventual consistency. And the idea there is that you can have a cluster or distributed uh, servers all running your NoSQL database, and they all talk to each other. Um, but rather than being built around that, that data, must be safe and robust at every step of the way. Um, the NoSQL databases mostly are built on the idea of higher performance and eventual consistency, so that if you make an update to one of the NoSQL servers in your cluster, it will be very high performance to make that update. Um, but one of the ways they do that is that they don't ensure that every server in the cluster has that update immediately. It's eventual consistency, so that if you make an update on one server in the cluster, it will eventually be on all the servers in the cluster, and ideally that eventually is a very, very short period of time. But it may or may not be, depending on server load and settings and all of that. But it will eventually be consistent across the whole cluster. So, again, this is going to depend on the application you want to use this database for. If you have, like an accounting server, or inventory server, you're doing online sales, you want to have that a relational database, so that when your inventory is updated, it updates immediately for every query. Some other applications don't necessarily need that immediate consistency, and so a high performance NoSQL database could be the right choice there. And then I mentioned, infrastructure servers and services as kind of the behind the scenes services of the internet and networking and Unix and Linux. Some of the things that they run are, kind of unsung heroes. They're behind the scenes, but they're critically important to the operation of your network or the internet at large. Uh, Things like the domain name system, DNS, the the actual service that runs that is a program called bind, and that's the service that when you call up a web browser and you type in google.com. Google.com is a friendly name that you and I understand better, but computers don't necessarily understand that. They work in binary code. They think in terms of numbers, and so there's an intermediate in there. There's the numerical address. It's kind of like if you're going to go to Uncle Bob's house, you say, hey, we're going to go to Uncle Bob's house, and that's the name for it. But Uncle Bob's house has an actual street address. It has an actual number that designates the address of that house, and it's the same for internet servers. You can have the name google.com or apple.com or Las Positas College.edu, and if you look that up using DNS, you actually get a numerical address that points to, and that's what the actual computers use to determine where to find that, and that's how the internet routing works to get you to that service. Um, Another service, Lightweight Directory Access Protocol, or LDAP. That's what, if you're in a Windows world or using Windows servers, you've probably heard of Active Directory, and Active Directory is a kind of a superset of LDAP. It's based a bit on LDAP. They can interact, but it's had features added and things specifically for Microsoft purposes and Microsoft's services, and for their kind of networking. But at heart, there is the LDAP protocol in there, and what that is it's not just authentication. It's directory as in user information, not directory as in file system location. So it's kind of like the phone book, but it can store more than just like names and phone numbers or names and passwords. But in most cases, what you'll see LDAP being used for is for back-end authentication. It's good as a centralized authentication system, so you can have all of your Linux servers configured to authenticate against LDAP instead of local password files. And then the users only have to change their password once, and they have a single login and password for all of the servers that talk to the LDAP server. And then there's another one is Dynamic Host Configuration Protocol, or DHCP. This is another one that you may be familiar with, maybe without even knowing it. But when you go to Starbucks or to school, and you open your laptop and you connect to the Wi-Fi, you don't have to put in an IP address for your computer manually. It's given to you by the server using the DHCP protocol, and that's as it sounds, it allows IP addresses and networking information to be configured dynamically. So your client connects to the Wi-Fi network, it makes a query to the DHCP server, and the DHCP server says, here's the address you're going to use while you're on my network. And development functions. Of course, every piece of software has to be developed, and Unix and Linux have a strong development heritage. As we talked about last week, they were designed to be multi-user, and they were kind of written by programmers originally, for programmers. So it was from the beginning. You could get the source code, and you could they were written to be, it was built to be programmed on. And right down to the command line shell that you use to interact with Unix and Linux in a terminal is built to be programmable as well. So you can write scripts that work directly in the shell and can automate things for you. And different shells have different strengths. But there's the C shell, which is built to be kind of familiar to C programmers. The commands are kind of like C programming commands, and it's built to be friendly to C programmers that way. And on Linux and Unix systems, besides the shell, many programming languages and tools are readily available. Things like Python, Perl, and Ruby are generally, if you do a default installation of a Linux distribution, you're going to have those tools probably installed by default, unless you're picking a very minimal install or that. But in a default install, you're going to have those tools installed and ready to go by default. Some other tools, may not be there by default. You may not have C compiler or Java or things like that installed by default, but they're readily available and easily installed. So pretty much, any kind of tool you need, any kind of programming you want to do is going to be readily available for you. When you're building a development system, like I said, when you do a default install, you get some programming tools, especially the scripting languages like Python and Perl and Ruby, and those are great for automating tasks and writing like web server backends and that. But for more heavy duty development, and especially if you're writing like C or C++ code, you're going to need to do a little extra work to set up your development system. You're going to install development libraries to work with, and headers and additional tools for whatever programming language you're going to be using. And one of the things that is nice about Linux especially is that all of the distributions also include source packages. So not only can you do an install and install a piece of software on your Linux server or desktop, you can also install the source code that that goes along with that package. So you can install a service and install the binaries and all the configs and all that, but then you can also install the source package, which will have all the source code to modify and compile that service. And I mentioned, scripting languages and other development languages. They're, basically, two kinds of, and there are variations, and some people, may call me out on this a little bit, but basically there are two kinds of languages available on Linux and Unix. There's compiled and interpreted. And the kind of trade-off there is productivity versus system resources. So An interpreted language or a scripting language is in general going to be, going to be made to be a lot easier to dive into and a lot easier to get something running quickly. Um, but it, but as it's an interpreted language, it's the code isn't compiled. You run the script, the raw source code, and the interpreter has to take that and compile it on the fly and make the program run. Whereas a compiled language, in general, is a bit more low level and a bit higher learning curve and more work to get into and to write and to get something going. You need the development libraries and you need headers and all of that. But once you've written the code and you compile it, the code is compiled down to a binary, uh, which is already it compiles down into the binary code that the operating system and the computer run directly, and so there is no interpreter sitting between there. So you get much higher performance and better utilization of system resources in general with a compiled program. Some of the compiled languages available on Linux and Unix are C and C++ and Java. And if you're using OS X or writing code for OS X, you're using Objective-C, which is another member of the C family. A little different than C++, but it's an object-oriented C language. And then some of the interpreted languages, the scripting languages, are things like Python and PHP and Ruby and Perl. Primarily, if you're using Linux or Unix on the desktop, it's going to be a graphical desktop, and at its base, it'll be running a system called X-Windows or X11. And that is the base graphical system for Unix and Linux. Provides all of the windows and basic primitives, but there are lots of other components on top of it that can determine what the actual look of your desktop is going to be. This provides the windows and primitives, and the Chrome can be provided by a window manager or a desktop environment like KDE or the GNOME or CDE, the Common Desktop Environment. Um, there have been some work on replacing X Windows with other systems, but most Linux and Unix systems, no matter how different they look than the older systems, are still running X Windows or X11 underneath with these desktop environments on top that handle a lot of the look and many of the functions now. So at base, what you need on top of X, like I said, is the window manager, and that's the simpler GUI application. It handles interactions with Windows, provides the menus, the Chrome, the frames around Windows and all that, and some management for finding applications and interacting. But it's the pretty basic Windows and menus kind of interface. And then on top of that, now you have the full desktop environment, and this is more of the full-featured interface. Uh, that includes things like login windows. So when you open your laptop and the login comes up, that's the desktop environment providing that, and it'll have more packaged utilities like file managers and things like that with it. And then even when you're using a graphical desktop, being Unix and Linux, you may have to, or you should probably be familiar and know how to use the console tools as well. And these can be used, directly by skipping the windowing system and booting your desktop up into a console mode where there is no graphical interface, or it's the terminal windows you have in your graphical interface. The primary means of interacting with the console is your login shell. Some of the popular ones, the more common ones are the Bourne shell, which is SH, or the Bourne Again shell, Bash. There's the C shell, the Korn shell, and the newest one that's gained in popularity and is actually a really powerful shell is the Z shell, which combines. It's kind of a take on the Bourne Again shell, the Bash shell, but with some different and very powerful features added onto it. Um, and then there are some text editors that you'll generally find on installed by default on Linux and Unix computers. There's VI, or the Vim editor. Vim is stands for VI improved. On most newer Linux distributions, you're going to find that you can run VI and edit your documents, but what you're actually running is Vim. Most systems now install Vim by default instead of the base VI. Uh, Vim has all of the features of VI and all the same interaction and commands, but then adds other handy things like multiple undos and other handy tools that the base VI didn't and doesn't have. Another very powerful editor, a text editor on Linux and Unix, is Emacs. And on some of the modern systems that may not be installed by default anymore, but it is readily available. It's a whole different editing paradigm than VI and Vim, and some people really like Emacs a lot better, and some people really like VI better. It's kind of one of those personal preference holy war kind of things. It's PC and Mac before there were PCs and Macs. However, I will say that no matter how much you like Emacs, and I know people who really love it and can do really, really powerful things with it, it is pretty crucial to also know the VI editor, at least the basics of getting around in VI, because VI is kind of the default text editor of Unix and Linux. And no matter what else is installed, you can always count on the VI editor will be there. And then there's the Pico or Nano editor, and these are not graphical, but console terminal interface editors that are made to be a bit more interactive, a bit more easy to use. How you think of a regular text editor. VI and Emacs have their own way of doing things, and the learning curve can be kind of steep, but it pays off with the power. Whereas Pico and Nano are great text editors, but they're really made to be much easier to jump into and use without the learning curve. And then other crucial, there are many crucial console tools. But along with these, when I keep saying that things may not be installed but are readily available, the way you're going to get those is with the package management tools. On a Red Hat system, the package manager is RPM, and you can use that to interact with packages locally, and then the tool to get packages and to download and install packages is Yum. And on Debian systems, the package manager is dpackage, and that's what you use locally. But to download and install packages, you use apt-get and apt-cache. On Red Hat, that's a single command. Yum will search and find, search, and list packages, and also install them. On Debian, it's split between the two functions. So apt-get will download and install packages, whereas apt-cache is the tool you use to search for and list packages that you can download and install. So in the lecture, I've covered the roles of a Unix and Linux system. Be sure to do the reading on the Safari book site. And as some of you discovered, there was some question about this. The best way to get to the Safari book site is to log into acm.org first, and then click on the Safari book links in the sidebar, and that passes your authentication for your ACM account onto the Safari book site and lets you log in. Your ACM credentials don't work directly on the Safari site. You need to go through acm.org first. But once you've done that, then you can copy and paste links to the books there once you're authenticated. So for this week, read the book, read Chapter 1, the Bash Basics chapter, in the Learning the Bash Shell 3rd edition book there. And then be sure to do that reading, and then there's Quiz 2 this week, which as with every week is due by 12:01 next Monday morning. And then, as I mentioned earlier, I'm going to be posting start for discussion topic for week 2. This week I'm going to post a prompt for you to kind of give me a little bit of background on your experience with Linux and Unix so far. If you're coming to it fresh, never having used it, I know that based on the screenshots and discussion, some of you have already picked a favorite Linux distribution and are already running Linux on your computers, and some of you are probably installing it for the first time. So I'll post a little thing to prompt to kind of give me a little bit of background on your experience and knowledge of Linux and Unix. Thanks so much, everybody, and I will talk to you again next week.